Oh, yeah, really.
Okay, today we're going to take a few notes. That's not the schedule, sorry. Ignore it. I forgot to put the new schedule this morning, but alright, we're out. I think we're out of here at what, 9? Something like that on the dot. So 9, yeah, 9:01, something like that. Alright, today I want to take a few notes, what we're going into. Then after we're done, with the intro, talk about a couple problems. If you need to ask a couple questions about it, that's fine. Then we're going to immediately go back to your homework and discuss what you had due for Friday, and I'll give you some time to work on it. Now I know some of you might already have it done. Perfect, you can work it wherever you need to. But I want to give you some time that you can be in class and ask some questions, because yesterday I gave you, I think, no time at all. It was, what, last 2-3 minutes, something like that in class? It wasn't very long. So I want to give you at least some time today you can actually work on it and ask questions. But we're on the second section today. P.2, again, it's prerequisite stuff, so I know a lot of the stuff's like, Ward, we already covered this in Algebra 2. I spent like a long time in Algebra 2 covering this. It's nice to see it in the first section, so that when we get to those later sections that are difficult, you can fall back to something you at least know that you feel comfortable with. Okay, we're doing the laws of exponents. Laws of exponents. Now, the reason why we're doing this is because if you notice the homework that I assigned, there was just a lot of adding, subtracting. Every once in a while you distributed a number through a parenthesis, but there wasn't really multiplying polynomials together. That's what we're doing here. We're multiplying and somewhat dividing kind of easy stuff, doing like terms. So that's what we're going to be looking into, okay? So we're doing laws of exponents. There's a couple laws that we need to talk about. So there's a couple different forms. So the first one we're going to look at is doing a power rule. So there's different versions. So there's just straight up multiplication, or product rule, which quote unquote is the product rule. I'll show you that here in a second. There's doing exponents, so exponential form, which is a power rule, and then there's a power of a power rule. So then it's power on powers. So those are like the 3 basic forms. Those are your basic ones you learn in Algebra 2. And I'll go through them, so if you're like, I don't even recognize what that says, like what does that mean? We'll go through examples what we're talking about. After those 3, then you just have some basic ones, like you have negative exponents. So that's one of the other things we'll talk about. Negative exponents. And 0 exponents. The goal today is just to intro it, talk about it, make you feel a little bit more comfortable with it, and to talk about like where did it come from? Because maybe you never saw that. Maybe you don't know why 0 works out the way it does, or negative powers work out the way that they should. I'm going to try to hopefully explain it the best I can, so it's easy and you're like, oh, that now makes sense to me. Now I understand why it does that. Okay, and again, I will always try to give you a couple different outs in case, like, I show you the rule, the actual rule that they teach in class, and you don't like it, there's always a safety catch, so you can do it a different way. Okay, questions, comments, concerns about what we're doing here? Okay, let's start with the first one. The first one's like the go-to rule. It's the rule that it explains a lot of stuff, so let me explain. So this is the product rule. You have 2 items being multiplied together. Now, I'm going to choose monomials only today. I'm not going to go binomials or anything like that. We'll go to those upper level stuff later. But I'm going to just pick 2 easy items. So 3xy squared, and we're going to multiply by a 5x squared yz. All right, this is just product. Product means to multiply. That's all we're doing. We're multiplying 2 items together. They're monomials. It's single items being multiplied. How I know they're monomials, not binomials, there's no plus or minus signs in between any of the variables or terms. So these are single items being multiplied together. Really what you're doing, this is my best way to explain to people, you're just doing normal multiplication. That's it, normal multiplication. If you know what the numbers are. What I mean by that, like the leading numbers out front, what are the leading coefficients here? 3 and 4, right? That's really the only math you can do. Because I don't know what the other variables are, so you really don't multiply those together. So you're just going 3 times 4. And then everything else just gets thrown in the back. because I don't actually know what the variables are, so I can't actually multiply those numbers. So what I do is I just throw them in the back. Now you don't actually have to write this, but I just throw all the letters in the back, like such. And no, you don't have to always write that. That's just what I do in my head. I just throw them in the back, I forget about them, and I just do the math that I know. What's 3 times 4? 12. You're pretty much done. I mean, that's pretty much the answer. You're looking for 12. The only trick is, you just have a bunch of letters in the back, right, that we couldn't do anything with. So if you can't do anything with these, just combine them down using the basic rules of exponents. That exponents means that you have a bunch of these letters. So because x squared just means that you have 2 x's sitting there. That's what this means. Or the y squared means you have 2 y's sitting there. That's what that means. And then you have the z in the back. Because I can't actually multiply those things. So the definition of an exponent means you have 2 of the bases being multiplied together if you can do it. Well, I can't. I can't multiply these because I don't know what the numbers are. So I'm just going to combine them down using that definition of an exponent again. That an exponent means that you look at how many bases are being multiplied together, and that's the power on it. So since I have x's being multiplied, they're all the same base, I just make them that there's 3 of them. Because I can't do anything with it. Well, the y's in the back, they're being multiplied, so those are bases. So the shortcut is you can just write that you have 3 of them. And then the z, I only have 1 of them. Now you don't have to put a 1, I'm just putting a 1 to show you that you can do that. Does that make sense, like where it comes from? Now, that is not the rule that you learn in, Algebra 2. They teach you this weird little shortcut where you take 3 times 4, and then what you do in Algebra 2, or Algebra 1 really, is you add those powers like this. That's what they show you in class. Like, oh, you add 1 plus 2, because 1 plus the 2 here. That's just the shortcut that they teach you. And then for the y's, the same thing. The y is what? 2 plus 1. And then the z is in the back. And then that gets you to this answer anyway. Okay? Me personally, when I think of this problem, this is just how I think of it. Okay? You can multiply numbers you know. Everything else, just throw in the back. Don't worry about it. Just throw in the back. You can combine them later because you can't multiply them. That's a product rule. Most people probably do it that way, right? You just add the powers like 1 plus 2, and you just do it in your head, do it on the fly. But this is the real math. Now, do I care which one you do? No. Whatever works for you, do it. As long as you can keep it straight in your head. Questions, comments, concerns about any of those? Like the rule behind it. Okay, I think it makes sense. It's pretty much what you've seen for a long time. And if you haven't, well, there's a little starter for you. Okay, let's talk about the power rule. So exponents with powers. So this is an exponent or power rule. So when you have one item on the inside, just single item, and there's a power on the outside. Single item, not multiple. Because the powers of powers, this rule is when you have multiple items on the inside. I only have one item. So the trick was that I think they teach you in Algebra 2, is that you're just supposed to multiply these two numbers together, right? That's what they teach you to do. Okay, you're gonna go 2 times 3, and you go, that's x to the 6. Like that's what they teach you. But how many people have actually seen y? Why is it 2 times 3? Well, it's just what I just showed you a little bit ago. That if you were to actually, instead of like trying to remember the shortcut, where you multiply the 2 times 3, if you were to actually use like that definition of what an exponent really means, that an exponent means that you have so many bases multiplied together, you could change this problem so that it mimics the problem we just did, a minute or 2 ago, just the normal product rule. So if like you could remember, do I add or do I multiply them? You could just do this. What is that? X squared to the 3rd. You could choose to go, okay, this is my base, that's my exponent. So an exponent of 3 means I have 3 of the bases. X squared, X squared, X squared. That's what it means. You have 3 of the bases multiplied together. That's the definition of an exponent. Well, all these are squares, so these are bases with power. So I can make them, using the definition of an exponent, I can separate them into their own bases. This one has 2 x's as well, and that one has 2 x's as well. Well, the problem is, like, I don't have any numbers. I'm not taking 3 times 4 like the last problem. I don't have any digits. I just have a bunch of letters here. So since I can't multiply the letters together, we'll just do the definition of the exponent going backwards. I look at, these are all the same bases. So we're going to use the base of x. And how many are there? There's 6 of them. That's the rule. That's why it works. That's why this is the shortcut that you use. Make sense? Like what you can do? Okay. I don't need to always just know one way. It's nice to know 2 in case you get really stuck. Like you're that person like, do I add or do I multiply it? So I don't really remember. You could go the real math route, just remember what the definition of the exponent means. You can separate them out, and then you can combine them later. You don't have to remember the shortcuts. The shortcuts are nice, don't get me wrong. Like, yeah, most people probably do that. 99% of people just do this. They're shortcuts, they know them. It's just, it's nice every now and then to know like why we do it. We're good? Okay, that's a power rule. Pretty straightforward. And then the last one here is, I don't know why they separate these in Algebra 2. It's almost the exact same problem. It's a power of a power rule, that's what they call it, but it's doing something like this, where you have a parenthesis, they put multiple items on the inside. 3x to the 4th, y to the 5th, and this is all to the 2nd power. So now you have multiple items on the inside. To me, personally, I know they say it's power rule. It's the same problem you just did. It's just an exponent with a power outside the parenthesis. Now why I know that this is weird is that you have multiple items in here. Now I know it's still a monomial, but you have multiple terms, right? Items. So what's the shortcut you guys remember from like Algebra 2 or Algebra 1? What was the shortcut that they train you to do? How do we do a problem like that if there's a square on the outside?
Square everything on the inside?
Yeah, it's like a distribution rule kind of thing where you just hand the 2 to everything, right? So I'm going to put the 3 to the power of 2, the x to the 4 to the power of 2, and the y to the 5th to the power of 2. Like that's what they train. Now, obviously you wouldn't write like that. Most people just like draw a little arrow like that. You're going to hand it out. But do we add or multiply those numbers? What do we do? When I handed that 2 out, you multiply, because it's still the same rule that we just did, right? Still that rule there. So you're going to multiply. So this will turn out to be x to the 8th. That'll be y to the 10th. And this 3 squared is a 9, not 6. That's the shortcut that they train you to do in Algebra 2. Some people like that. It's like, okay, that makes sense. Now, obviously, you wouldn't write it like the way I'm doing it. I'm just trying to show you why it works. But the real math behind it, we can fall back to this. Again, you can go back to that definition of what an exponent actually is, like you're taking the bases and separating them, and I'll do the same thing. So that's 3x to the 4th, y to the 5th, squared. So this is my base inside the parenthesis, and I have a power of 2, an exponent of 2, so that means I have 2 of the bases. So 3x to the 4th, y to the 5th, and we're multiplying that on another one. That's the power of 2 means. You have 2 of the bases being multiplied together. Well, if you look at that problem now, what I just did, that's coming back to here. It's going back to what we originally started with. It's the exact same problem I started with today. And that explains why these are the answers you get. Because you would rearrange and move the 3's next to each other, because that's just commutative property. You can move things around as long as they're all being multiplied. They're all being multiplied here. I can put the x's next to each other. Put the y's next to each other. And then you can start separating and then all adding them back up. But it starts to explain, like it starts to reason like why the shortcuts work the way that they do. Okay, questions, comments, concerns about the basic laws of exponents. Now obviously you're thinking, okay, we're going to be doing a lot harder, more challenging stuff than this. And you're right, we are. Especially when we get to the work that we're going to be doing. Like tomorrow I'll jump in pretty heavy with this stuff and I'll give you some real problems that you'll see in the book. But this is the start, right? You gotta know the basics. You gotta know how to multiply, how to deal with power, how to deal with power if there's multiple items on the inside. Okay, are we comfortable with that stuff so far? It should be easy, right? It should be hopefully a kind of a review if maybe you didn't remember how to do that. Might be new to you, but it's two ways, they work out the same way. Okay, let's do negative exponents of 0, and then we're done for the day. So I just want to start with a light introduction today. Okay, negative exponents. Now, this is the one that I want to explain why it works. 5x squared y to the negative 3 over 4w to the negative 4 z to the 5th. Okay, I know I'm going like pretty intense just right off the bat here. This is a negative exponent, right? Certain items up here have negative powers. There is a shortcut. Well, what they train you to do in Algebra 2 and Algebra 1 is that when you see a problem like this, the trick is to take any of the items that have negative exponents. So in this case, I have two of them. I have the w here, and I have the y. If they have a negative exponent, those will move. Those are the only two that are going to move. So you'd move the y down, the w up. It goes to the opposite side of the fraction bar. So 5, the x squared will stay where it's at. It looks like the w will go up. So the w will join those on the top. And when you move it, it becomes positive. It's like telling you it's on the wrong side of the fraction bar. And the y will go to the bottom, and it will join the 4 and the z. Yeah? Okay, now obviously, that's like the rule that they train you, and then after you move it, then you can start simplifying things around. You can move, I just move them first, and then after that I simplify. Okay, questions, comments, concerns about what a negative exponent does? Okay, now, here's my question to you. Okay, I'm going to come back to this original problem. What if I put a negative in front of a 4? What would happen? If I put a negative in front of the 4 on the original problem, what would happen? Would it move? Would it stay? What would happen to the negative sign? What's your initial thoughts? Right or wrong? Just throw it out there. What do you think?
Stay.
It stays. It does stay. Why?
It's constant.
Yeah, it's constant, right? Was it a power? Was it a negative power on the 4? No. If it's not a negative power, leave it. You're absolutely right. Just leave it. It stays. It doesn't matter. In fact, you can move the negative sign, and this is still the exact same answer. Still the same answer. It doesn't matter where the negative sign is. It could be there, it could be on the bottom, it could be right here. It's all the same. It's still negative. The answer is negative. Now, if there's two negative signs, sure, they cancel. But what I'm saying is that initially, you don't just move the 4 because I have a negative number or a negative sign in front of it. You only need to move things that have negative exponents. All right. So hopefully that explained a little bit, because some people do get caught on that little rule every now and then. Now, anyone know why this works? Why negative powers move things? Okay, let's talk about it. Because I'm almost betting no one's ever seen this in here. Why does it actually work? We're going to stick with numbers. We'll do it for numbers so you can see it. Well, it's 2 to the first power. 2, right? 2 to the first is just 2. 2 to the second power. 4, right? Because you have 2 of the bases, so that makes 4. 2 to the third power. 8. 2 times 2 times 2. 8. And you can keep going a whole lot. You get the pattern. 2 to the 0. Aha. It is 1. Let's talk about it. Because this is going to lead us into, it'll talk about why the 0 power is the way it is, and then it'll lead us to why negative exponents work. 2 to the 0. Well, here's how I think of it. You have this pattern. 2 to the 1, 2 to the 2, 2 to the 3. Every time you went up, the trick was you multiplied by 2 on the previous number. 2 times 2 is 4. 4 times 2 is 8. So every time you add an exponent, you multiply the previous answer by another 2, because you're going to add another 2 on it. Well, it works the same way if you go backwards. If you go back, you take the previous answer and you divide by it to the base. So if I had 8 divided by 2, you get 4. If I had 4 and I'm going back, I divide by another 2. So 4 divided by 2 is 2. What's 2 divided by 2? 1. That's why it works. You follow the pattern. You divide as you go up the rank. Okay? That makes sense. You went 2, you divide by 2, went back to 1. That's why it's 1 every single time. What happens if I go negative? You're going one more rung up again, right? So I'm going to go 2 to the negative 1. So I'm going to go up the rank again one more time. What do I have to do again? Divide by 2. Well, what's 1 divided by 2? Half. 2's on the bottom. Same thing. 2 went to the bottom. That's why negative exponents work. They took the 2, they moved it. Now it's on the bottom. You can see it right there. It's a perfect example why it works. And you can do it again. If you put like a 2 to the negative 2, guess what? You're just moving that to the bottom again, and you're going to get 1/4. Because you're going to put another 2 on the bottom again, because it's going to move down. Makes sense? Like, how many people have actually honestly seen that before? Okay, 1. Okay. Most people don't. They just don't see like, okay, why does 0 work the way it does? Why do negative works the way that they do? That's it. You're actually seeing it right there. That's the reason why it works. That's the reason why there's a rule to it. Now, you can apply that to variables, you can apply it to anything. But just remember, anything to the 0 is a 1. Anything to a negative power, you just move it to the bottom of the fraction or move it to the top, depending where it sits. And it still works. Okay, I'm done for the day. Off my little soapbox here, talking about the stuff. You have the rest of the time today to work. You have about 10 minutes or so. Kind of work, you can work on the assignment. You gotta work on the book checks. Got those all taken care of. Assignments due Friday. So again, if you get it done today in class, or you get it done at study hall or whatever you have today, senior study hall, you can just put it in a back basket. I got a basket in the back, you can just walk in through it. Just make sure, I don't know if I told you this yesterday, top of my paper, in case you're new or just don't remember, I do require that your name's up there, the date somewhere, and again, it doesn't have to be in this order, just name, date, you need the page numbers, so page 15, blah, 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 and you need what period you are. So period 1 pre-calc. The reason being is I need to see how you're doing your problems. And I need to see what problems you're doing and what page and period you are in case you turn in later in the day, I can get to the right period. Question?
Can we work like with a partner?
Yeah, go ahead. You can write, you can talk, you can.
Alright.
But make sure when you turn it in, you have your own papers.
Yeah.
I have no problem with that. Lively conversation is a good thing. You can figure stuff out.